Hi, hello. Um, Today I want to talk about Virtio networking and Vhost-net. So I often heard this Virtio networking Vhost a lot from DPDK mailing list. I have not understood the 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 technology behind it and the how this come to being. And so I found a very good article, blog article from Red Hat recently. So this is one of the blog introduction to Virtio networking and Vhost-net. So, and in this article, it talks about how Virtio was developed and how it integrated into the QEMU process and Open vSwitch. And yeah, so it's very good article, and it has a very nice diagram and to talk about the architecture. So this is an introduction, and so like for example, this diagram, say you have a virtual machine running in KVM hypervisor, Linux kernel KVM hypervisor. So how the network packet pass through between uh, uh, the host kernel and the guest kernel. So this is a basic diagram, and so like this is for data plane, and this is for control plane. So you have a driver running in the host kernel, which is called Vhost-net, and you have a network driver running in the guest kernel, which is Virtio-net. And so libvirt is like the front end interface to the QEMU process. So the QEMU process is to run your virtual machine, your typical virtual machine. So this diagram looks pretty straightforward, and yeah, so that's this introduction about Virtio networking and the Vhost-net. Let's see if it has Open vSwitch in this article. Okay, so here is a diagram with Open vSwitch integrated in this architecture, and so for Open vSwitch in your host user space, in the hypervisor user space, you run Open vSwitch daemon. It has two main process. One is OVS-DB server for storing the configuration, and the OVS vSwitchD for data plane. So again, in the hypervisor kernel, you have Vhost net driver. In the guest kernel, you have Virtio-net, and with Open vSwitch, it's like you have this is the physical port to the external world, and if you have a packet from this guest virtual machine, and eventually it will go through Open vSwitch OVS kernel forwarding plane. It will go out to the external world, and so for southwest traffic, no, for south-north traffic for north-south traffic. And but you can also have another virtual machine running on the same hypervisor. So that will be east-west traffic, and also it goes through the open vSwitch. So yeah, that's the basically how this Virtio host and Virtio-net work together. And so after this basic instruction, it has another article talk about how the Vhost-user came into being, and how the Virtio networking and the DPDK work together. So again, here is the very nice diagram, and so this is Vhost-user OVS DPDK, and so you already see how open vSwitch work with the Virtio-net and Vhost-net. So this is in the basic introduction. Say when you run an OpenStack private cloud, OpenStack usually integrated with the Open vSwitch, and when you start up a virtual machine in OpenStack, and the underlying network is look like this, right? You have a virtual machine, you have a guest Virtio-net driver running in the guest kernel, like a typical Linux virtual machine, and in the host hypervisor, you have a Vhost kernel driver, and so Open vSwitch also have a kernel driver for data plane packet processing. So this is fine, and but the performance is not that good. That's why the DPDK come into this picture. So this is another article about the DPDK, and so this is a good diagram here. Is that you can see, so this is a hardware network interface, right? So this is a hypervisor kernel, the host kernel. As you can see, there's no more Virtio Vhost-net driver anymore in the host kernel, because it's moved to the user space. Here is the user space, because the DPDK is a user space network driver to process the data plane packet. And so instead of using Vhost in the hypervisor kernel, now the packet is processed in the hypervisor user space. So this is the Open vSwitch integrated the DPDK user space driver, and it has a driver called a Vhost-user, like you can see here. This is the DPDK Vhost-user driver, and so this is the data plane, the packet. So this is the guest virtual machine, and also in the guest virtual machine, you no longer has a Virtio-net driver in the guest kernel. Again, you can also run a Virtio DPDK driver that is also running in the guest user space. So like everything moved to the user space. everything moved into the user space for fast packet processing, and without the guest kernel or the hypervisor kernel involved. And that's a very good performance improvement. And later I'll do a demo to you. And so yeah, and so this is a very good article too, and I will put the link in the video later, so you can read. And so in this blog, it has other. So this is the previous blog article I talked about, Virtio networking and Vhost-net. And this is a deep dive into the Virtio networking and the Vhost-net. So that's more technical detail, how it works together, and for architects or developers or hackers to understand the technical detail. But this article and this DPDK article, you will have a very good understanding how the overall architecture looks like. So with that said, I want to do a demo here. So my virtual machine would be a big IP, and so this is my hypervisor. I have open vSwitch running, and also with DPDK running together with open vSwitch. I can show you right now. I have two open vSwitch bridge set up. So one bridge is this bridge OVS BR0. So this bridge is configured with DPDK. As you can see, the underlying PCI device, the type is DPDK. So remember, with DPDK in the guest and in the host, all the driver runs in the user space using DPDK driver, using DPDK. Okay, so this is one bridge. And also remember, I use the DPDK Vhost-user. So this is a second bridge. It is the default Vhost-net and Virtio-net architecture, which means in the host kernel and in the guest kernel, the driver runs in the kernel space. No DPDK, no user space driver involved. So in my big IP, I provisioned this both bridge to the big IP guest. So my big IP would have two network interface. One is back end. One is backed up by the open vSwitch default bridge, which is a Virtio Vhost-net and Virtio-net architecture. And for DPDK bridge, that's the Vhost-user and Virtio-pmd architecture. So again, let's look at the diagram here. See here, this is for DPDK, Vhost-user, Virtio-pmd architecture. That's DPDK in the picture. So here, Virtio-pmd driver in the guest user space, Vhost-user driver in the host user space. Okay, so that's for this bridge, DPDK bridge. And another is Vhost-net, Virtio-net architecture, which is this architecture. Virtio-net runs in the guest kernel. Vhost-net runs in the host kernel. Okay. So let me do a. So that's the Open vSwitch bridge setup, and so I can show you my big IP guest running here. This is my big IP guest. So we can see the libvirt XML provision example here. So I have 3 network interface. So one is for management, so we don't look at it. So this is 2 network interface for the data plane. You can see here one network interface I defined as Vhost-user. That is for DPDK, that is provisioned from the DPDK bridge. And as you can see here, I use DPDK Vhost-user client. And so I have I provisioned 2 queues for the network interface, and you can define the number of queue here. But if you without this queues, by default it is only 1 queue. And so this is a network interface provisioned from the Open vSwitch, Vhost-net, and Virtio-net architecture bridge. And as you can see, the detail is different here. So it's called a virtual port type Open vSwitch. And the driver would be Virtio. I also have 2 queues here provisioned on this interface. So it has two network interface provisioned for data plane, right? So as you can see, the source bridge name is different here. Okay, so and that's how the guest is provisioned from the libvirt. And let's log in. This is my big IP. Okay. In this big IP, I have two network interface. Okay, so this interface is the interface backed up by the DPDK bridge, Open vSwitch DPDK bridge. So this interface is backed up by the default Open vSwitch bridge that usually comes with your OpenStack deployment. Okay, remember? And so on this DPDK, on this big IP, we have a few driver options. So I used the XNet, which is a DPDK driver from big IP. Okay, here. So one way you can use this command to monitor the big IP driver performance. And as you can see here, there's 2 net interface, 1.2, 1.1. It both use the XNet DPDK driver. Okay. So DPDK driver is also in the big IP. This DPDK driver runs in the user space. Remember, it runs in the. It does not runs in the big IP guest Linux kernel. This is user space. Okay. Remember, here, Virtio-pmd. That is equivalent to the XNet driver in big IP in the user space. not in the big IP, not in this big IP guest kernel space. Okay, so now I would compare the difference, the performance difference. Remember, 1.1 is backed up by the DPDK bridge. 1.2 is backed up by the host kernel Vhost-net driver, which should have a poor performance. But let's run a load test to confirm that. So when we monitor the big IP driver performance, we will look at the blocked state. So if a lot of packets get dropped or get blocked in the transmission side, we will have idea of the backend driver on the host probably is a bottleneck, and so say if you have a more bottleneck in the host driver, you would see more blocked state. If you have a better performance in the host driver, hypervisor host driver, you would have a better result with blocked state. And so we want to compare these two interface and see which one has more blocked state and which one has less blocked state. Okay, let's run. So this is okay. Let's get it to our load tester. Where is our load tester? Okay, never mind. I will log into my load test box. So in my load tester is also runs DPDK, and I will run Apache bench. Okay, and so Apache bench. So this time we'll use DPDK 0 port. DPDK 0 port. Okay. So this is my node tester. I will run Apache bench to a virtual IP address on the big IP, and just the HTTP request. And so this traffic would where's my big IP? Virtual. So this virtual is hosted on the VLAN, on the 1.1 VLAN, 1.1 interface, and the VLAN on the interface. So right now we should see some statistics from 1.1. That's for the DPDK bridge, Open vSwitch DPDK bridge. And okay, let's start the test. So this is our Apache bench integrated with MTCP and the DPDK driver. So this is my load tester. And now let's go to the big IP and watch the statistics. as you can see here, 1.1 interface. It's the sent packet is incrementing, right? So this is traffic is passing through 1.1 interface that is backed up by the host open vSwitch DPDK bridge. And you can see here we have blocked the statistics with 0 counters, which is good, right? Okay, so it looks good. No packet drop here also. Okay, so now, so the throughput is like 39, about close to 400 megabit per second. Okay, let's stop this. And now we want to test the open vSwitch Vhost-net bridge in the kernel, in the host kernel, and let's change my load tester because I wanna send the traffic through another port. I needed to change my load tester port. Maybe I can next time I can draw a diagram. So for the test demo example. So this time I will send it to a different virtual server that is on the 1.2 interface VLAN. Okay, so let's start this node test. So right now 1.2 has no counter, okay? But immediately, yeah, so okay, we have a 150 megabit per second, much less throughput than the open vSwitch DPDK bridge. And we should see some counter now. Did you notice anything? 1.2, it's send traffic, send packet, but in the blocked states, it's a huge number of blocked states, which means the packet is full in the transmission queue, and thus it's blocked. So you can see the performance here, right? It's incrementing quickly. But instead, for this 1.1 interface, in our previous test, it has 0 in the blocked state. So huge difference. And I think that's what I want to cover today. Shows this performance. So for the open vSwitch Vhost-net, the throughput, yeah. So as you can see here, in, out, not much, and anyway, yes, I think that's I want to cover today. And again, this article is very good to help you understand the overall architecture. And if you want to be more technical, go to this. Wait, I have another link. Go to this. Read this article, and it explains the detail of how the packet is transferred in the memory and the VRAM stuff and all this detail, you know, KVM guest, KVM hypervisor. Yeah, this is very technical stuff, and if you wanna know more about it, I will post those links in the video I posted, and yeah, it's very good articles from Red Hat. Okay, thank you for watching. Bye.